Okay, so in this class, we will take a look at how to graph some functions. So when we're trying to graph a function, we usually graph a function of an equation that is in this form. So we have y is equal to f of x. And an equation in this form can be graphed on a coordinate system known as a Cartesian coordinate system. So you may already be familiar with a coordinate system like this. So this is a Cartesian coordinate system in 2 dimensions, right? So in this Cartesian coordinate system, we have an x-axis and a y-axis, and the combination of this x-axis and y-axis creates something known as the Cartesian plane. So this is a Cartesian plane, which is basically just a 2-dimensional plane that is created when we combine the x-axis and the y-axis together. And on this Cartesian plane, we can plot or we can specify any point uniquely using an ordered pair. So if we have an ordered pair like this, so this is just a pair of elements and we call this an ordered pair, or you can just call this a coordinate. So the first element is our x coordinate. So this is the x coordinate. And our second element is the y coordinate. Right, so for example, if we had a point like this where we had 2, 4, right? So in this case, our x coordinate is 2, our y coordinate is 4, right? So if we were to plot this point on our Cartesian coordinate system or on the Cartesian plane, then what would we do? So the origin of this Cartesian plane is the point 0, 0, right? This is the origin, which is symbolized by this O. And in order to plot this point, we will go 2 units on our x-axis to the right. So we will have 2 units. So this is x is equal to 2. And then we will vertically go 4 units upwards. So we have 1, 2, 3, and 4. And this will be y is equal to 4. So our point will be here. And the coordinate of this point will be 2, 4. Right. So we can specify any point uniquely on this Cartesian plane. Right. So if we consider, let's consider some function f of x is equal to x plus 2, right? So this is a very simple function. This is a linear function, right? So this is a linear function. And we say that this is a linear function because the highest degree of our variable x is 1. So this is just x to the power of 1. If we had a function with x to the power of 2, then this would be a quadratic function, right? So what do we know about the graph of a linear function? We know that the graph of a linear function will just be a straight line, right? So for x plus 2, we will have a graph that looks something like this, right? So this is the graph of x plus 2, right? And this is our x-axis, so this is our y-axis, and these arrows indicate that this line is still continuing towards the positive infinity. So as x increases, our values of y increases and this line continues to carry on. And similarly, the same thing happens in the negative x direction. So as our values of x become more and more negative, our outputs become more and more negative, and this line continues in the negative infinity direction. Right, so this point would be 0, 2, and this would be minus 2, 0. Right, so this will be the graph of a linear function such as this. Now, if we take a look at a different function, let's say we take a function that is parabolic. Right, so this is a parabolic function, right? And we may already know that the graph of a parabolic function would look something like this, right? So this is an upward opening parabola. And this is upward opening because you can see from the coefficient of our x is that this is just a positive coefficient. This is just 1 times x squared. If we had f of x is equal to minus x squared, then we would just reflect the graph of this. We would just reflect this graph along the x-axis, and we would have a graph that looks like this instead. Right, and this would be a downward opening parabola. And once again, these arrows indicate that it's continuing to increase in this direction and this direction as x increases or x decreases. This is x, and this is the negative x direction. Right, so now another graph that we can take a look at is if we have some function such as square root of x. Right, so this is a root function. Now we can find the graph of this, and it would look something like this. So this would be the graph of square root of x. Now the great thing about being able to graph a function is that from the graph of the function we can determine the domain and range more easily. Just by looking at the function, or just by looking at the graph of the function, we can easily determine the domain and range, right? We know that the domain is just a set of all possible inputs, and the range is the set of all possible outputs. So if we take a look at the graph of this function, we see that all the values of x are positive, right? There isn't any negative value of x that corresponds to some output. All of these values of x correspond to some output here. So all these values are positive. All these values of x are positive. And similarly, all of the corresponding outputs are also positive, right? And we can see that from this graph. So that means that the domain is the value of all x, which is an element of the set of all non-negative real numbers. So we start from 0 to the positive infinity. And similarly for the range, we have y is an element of the interval starting from 0 to the positive infinity. Right. So once again, we don't have any negative outputs. So for some value of x, we don't have some negative output, right? All of the outputs are positive. And once again, we also explain this just by from looking at the equation itself. We know that the argument for a square root, right? So the argument will always be non-negative, meaning it will be greater than or equal to 0. Now, moving on to a function known as an absolute value function. Right, so for this case, let's say we have a function f of x which is equal to the absolute value of x. So these vertical bars to the left and right of our variable x indicates that we're taking the absolute value of x. And if you're unfamiliar with what an absolute value is, let's say we have some constant a and we want to take the absolute value of this constant, right? So we want to take the absolute value of this constant. Now, if a is greater than or equal to 0, if a is non-negative, then the absolute value of a will just give us back a. But if a is negative, if a is less than 0, then the absolute value of a will give us minus a. So basically, let's say we have the absolute value of 2 and the absolute value of 0, right? Then the absolute value of 2 will just give us 2 back, and the absolute value of 0 will just give us 0. But if we had the absolute value of some negative number, say minus 3, then we will get something positive, right? We will just get the integer back, but the sign will be flipped. Minus 3 will become plus 3, right? So the absolute value of any number will give us something non-negative. Right, so if we were to graph this function, right? So we know that if x is greater than or equal to 0, then f of x should be equal to the absolute value of x, which will be just equal to x, right? From the explanation that I have said previously, f of x should be equal to x if x is non-negative, and we know that y is equal to f of x. So when x is greater than or equal to 0, we will have the graph y is equal to x, right? Because once again, when x is non-negative, then we have, say, if we had absolute value of 3, we will just get 3, right? We will just get x back. But if x is less than 0, then we have y is equal to f of x, which is equal to the absolute value of x, but this will be equal to minus x, right? And we can show this because if we consider x to be minus 2, then when we take the absolute value of minus 2, so in this case our x is minus 2, then this will give us 2, right? The absolute value of minus 2 will give us something positive, which will be, in this case, 2. So if this is x, this is minus x, right? So when x is less than 0, we have the graph of y is equal to minus x. Right, so if we were to graph this, then we would have, so this is the x-axis, this is the y-axis, and we know that this side of our graph is for all values of x that is greater than or equal to 0, and this part will be when x is less than 0, right? And we know that when x is greater than or equal to 0, we just plot the graph of y is equal to x. And if we don't know what the graph of y is equal to x looks like, it's just a straight line that is diagonal going through the origin, right? So we will graph y is equal to x, but only for this portion. So we will have a graph that looks like this for when x is greater than or equal to 0. But when x is less than 0, so if x is less than 0, then we will have the graph of y is equal to minus x, right? So we have a minus sign here. That means we have a negative slope. The slope of the line is going downwards, or the gradient is negative. And in that case, y is equal to minus x will have a graph that looks like this, going through the origin like this. So this is y is equal to minus x, and this is y is equal to x. But once again, we have this graph for when x is less than 0. So in this case, we will have a graph that looks like this for this portion. And this will be the graph of the absolute value of x. Right, so now that we've taken a look at the different types of graphs of some basic functions, we can now move on to something known as graph transformation rules. We will take a look at some graph transformation rules. Right, so now let's say we have a graph such as this, where we have y is equal to f of x. Right, now if I were to add a constant to this function, so let's say I have a function y is equal to f of x, so I have this function, but now I add a constant of c units. So let's say I add c units to this function. Then what happens to the graph of this function, right? So if c happens to be positive, right? If c is positive, then what can we tell from this? So if c is positive, we're adding c units to the y coordinates of every point, right? So if we had a graph of y is equal to x squared, for example, then if I add some c units to this function, let's say c is equal to 2, then I will have x squared plus 2, right? So what am I doing? I'm adding 2 units to each of the y coordinates of the graph, right? To each of the points on our graph, we're adding 2 units to the y coordinates. So if we have the graph of, So this is the graph of y is equal to x squared. Then for the graph of y is equal to x squared plus 2, then we will have a graph that looks like this. So we will have the exact same graph, except each of the points, the y coordinates will be increased by 2 units. So if, let's say, x is equal to 2, then for y is equal to x squared, y will be equal to 4, right? So if this point is 2 comma 4, then for the graph of y is equal to x squared plus 2, we will have the point 2 comma 6, right? So we just added 2 units to our y coordinate to get this, right? So every point on the graph of y is equal to x squared gets increased by 2 units for the y coordinates to give us the graph of this function, right? So if c is positive and we're adding c units to our function, then the graph gets shifted vertically. So the graph of this equation gets shifted vertically upwards by c units. And if we're adding, well, if c happens to be less than 0, if c happens to be less than 0, right, then in that case, we're shifting the graph downwards vertically by c units. So if instead, if we had y is equal to x squared minus 2, right, then in that case, the graph will just be shifted 2 units downwards. And we will get a graph that looks like this. So this will be the graph of y is equal to x squared minus 2.